So hey guys, welcome to the channel Learn Competitive Programming with CodeChef. So if you are new to the channel, this channel brings you a really great content on competitive programming, data structures and algorithms, and a lot of video tutorials for the CodeChef's contest. So please do subscribe the channel and turn on the bell notification. Myself Chirayu Jain, I'm a CodeChef educator, and the topic that we're going to cover in today's video is circular linked list on the series linked list. Okay guys, so now let us discuss the point on circular linked list, right? So we have seen the singly linked list, right? So basically circular linked list is also a type of singly linked list, but it has some additional functionalities. So let us see what is it. It is a type of linked list in which the last node is connected to the first node. So as we can see in the diagram that this is the last node conventionally, and it is connected to the first node. More technically speaking, there is no last node and first node in the circular linked list, but we can assume that if it was a single linked list, then this was the last node and this is the first node. So there is a connection between the last node and the first node. All the nodes are connected in a circular manner. So you can see a formation of circle, right? So these nodes are connected into the circular manner. What are the advantages of this? So basically there is no starting point here, if you see, right? So we can start it from here also. We can start it from here, and when we will see all the nodes, we'll end up here. So how we can track that, what is the starting point? So we can make that visited. Whenever we visit a node, we can make that visited, and whenever we again hit any node which is visited once, that means we have we have traversed the whole circle, right? So this is a point where we can use the circular linked list, right? So there is no not any node which is pointing to null or something, right? Every node is can act as a starting node, and we can traverse the whole circle, right? So there are multiple varieties of problems which can demand the use of the circular linked list, and like the implementation of Fibonacci heap, if you see, these are the certain areas where the circular linked list is used, right? So this is some basic about circular linked list. Let's try to see the operations on circular linked list. Okay guys, so now let us understand the operations on the circular linked list, right? So we are generally seeing three types of operations, that is insert, delete and search, right? So we can just sum up all the things in these type of operations, right? Generally these operations will be used to solve a problem on circular linked list, right? Let us see how we can implement those things. So for insertion, we need to insert a node in the circular linked list, right? So what are the possible cases that we can have? One possible case can be that there is no node in the circular linked list right now. So in that case, we need to insert the node, insert the first node. This can be a possible scenario, right? So we will see how we can insert the first node, and while inserting the node, what can we do? Because the first node should match the last node, right? The next of the last node should be connected to the first of the first node, right? Since there is only one node, so next of this node is connected to this node only. That makes it circular, right? So this is the possible scenario when we are making a single node into the circular linked list. Okay. What can be another scenario, right? So another scenario can be that, let's say I want to insert here at this particular position, so what I can do, the next of this is pointing to the head, right? Where head is pointing, right? This is the start. So what I can do, I can make the next of this point to this new node, and the next of this new node, right, should point to the first node. This is the possible scenario that we can have, right? So this is one way in which we can do. So generally when you are solving a problem of linked list, just try to write it down, just try to diagrammatically write it down and see what all changes we can do in the pointers, right? What all we can do in the pointers. Most probably that will help you out to solve anything in the linked list, right? Let us assume that we can just add a node here itself, right? So what can be done? Just think. We need to change the next of this node to the starting, right? And the last node should point to this particular node, and the head should also be modified to here. That's it, right? We can insert it here. So these are all things which help you to develop and write a proper code regarding a particular scenario in linked list, right? So this is the way. Similarly, same approach we can do for the deletion as well, right? Whenever we want to delete a node, right, first we will check that whether the list is empty or not, right? And if the list consists of only single element, then what we should do, we should remove this element and make the list as null. It is present at the end or the front, we should change the pointer. So what happens if it is present at the end? Just change the pointers, right? So we need to delete this particular delete this node, right, if it is present at the end. So what we will do, we will mark the next to next pointer is this one, right? So this next should point to this next to next pointer that will belong to here, and then we can simply delete this particular node, right? So that's the way we need to think, right? So generally we are following this trend, right, from the starting of singly linked list. Similarly, in the search operation also, we need to traverse the list, but one thing that we need to keep in mind while doing anything is that there is no way to judge that okay, this is the null pointer and we have reached the end. So what we can keep a track of is that if it is head and we are beginning from the head and we are searching, and whenever we encounter the head again, that means we have completed one single round of that circular linked list. So that's how we need to modify the operations that we are performing. There is nothing like null when there is a circular linked list formed. Initially, when there is like no member, it can point to null, but when there are certain members inside the circular linked list, then we should be taking care that okay, if this we are starting it from the here, the head is pointing here and we are traversing the list, and whenever again we encounter the head, that means we have traversed a one single round of circular linked list. That's all what we need to do. So these operations are pretty basic, like we have discussed in the singly linked list, right? Insert, delete and search, but the only modification is that the last node is pointing to the first node. That's how we need to change the pointer. So it will be more clear when we look at the code and understand that okay, this is how we are just implementing it, right? But one suggestion, that if you have any doubt or if you have like some understanding of this, just try to code it on your own and see like what results do we get, and that's how you can learn it, right? So now let us look at the code of this in C++. Okay guys, so now let us understand the insertion and deletion code, right? So let's start with the insertion one, right? So we have the new data. We need to create a new node with this data, right? So what we can do, we can create a node like this, right? Because we know that the type is the struct node, and then we'll make a pointer that is ptr, initialize it with head. First of all, we'll mark this new node data, right? So this new node data is equal to new data, and the next should be pointing to head, right? So if we're inserting at that particular position, which has the next as head, right? So the new node next should point to head. So there are two cases. Case number one, when head can be equal to null, and case number two, when head is not equal to null. So when head is not equal to null, that means that there is some data present, right, inside the circular linked list. So what we can do, we can just make that pointer which we have initiated here, that while the pointer dot next is not equal to head, as I have said that it is not containing null, so basically it will traverse the circular linked list and reach that same point again. While we are not able to reach that point, that means we are traversing the list, and we'll make pointer equal to pointer dot next, right? If we know that the next one is pointing to head, then what we can do, pointer of next should point to the next node. That means at the last we are inserting one node, right? Pointer of next, right? That pointer of next should point to this new node that we have, right? That's all what we want. Otherwise else what we will do, new node dot next equal to new node, right? So new node dot next equals to new node means that if there is no head in the circular linked list, that means that only 0 elements are present, right? That means it is the first element which we are going to enter in the circular linked list. That means that the next of this node should also point to this node because it is circular linked list. So that's what we are doing here. New node dot next equals to new node, right? So pointer dot next is pointing to new node, and new node dot next, we have earlier mentioned that it is pointing to head. So that means it is corrected in a circular manner. Now we need to modify the head as well. So head will be equal to new node. Right, so this is a way in which we can insert the node at the last and make it in a circular manner. Now it's your chance to make the entry, to make the insertion at different positions in the circular linked list, whether it is in the front of the circular linked list. That means before head you need to add it, after head you need to add it, and any other middle node that you need to add it, right? So it's your understanding. We have seen like how we can do this, how we can modify this, right? And if you want that I should make the video on any specific insertion also, you can tell me in the comment section. Otherwise you can try to paste your code whatever you have written, and let's see like what different approaches, what different kind of codes that we get in the comment section, right? So this is the first thing. Let's understand the deletion also. Deletion we'll do for most possible cases, right? So if head is equal to null, so here if you see we are passing the pointer to pointer, right? So don't get confused. So this is a reference to the pointer, right? So if we are initializing the node in the main function, we are not defining it globally, then we are passing the reference, so that at that particular location only the modification will happen, right? So we dereference that point and we get the head. If head is equals to null, then we'll simply return, because there is nothing that can be deleted from the circular linked list. Okay, so if head data is equal to key means the data that we need to delete, right? If head data is equals to key and head dot next is equals to head, what that means is that there is only a single node present in the circular linked list. That's why the head of next is pointing to head, right? We have seen the cases in the insertion, right? What we do when there is a single node, that new node dot next should point to new node, right? Should be equal to new node. So here if we check this condition, if that is equal, that means that there is only a single node present, so we'll free the particular head. After this, after the removal, there will be no node left in the circular linked list, so we'll make the head as null and we'll simply return. This is one possible case. Now we are checking for the case where we have multiple nodes inside the linked list, right? So we have seen there is no node, there is only a single node, and there are multiple nodes here. So what we will do, first of all, we'll make a node, a pointer that is last, initialized with head and one temp. We'll see the usages of this, right? So if head dot data equals to key, right? So at head only we had our value, right? So what we should do, at head only we had our value and there are multiple nodes. So we'll traverse to the point where we until encounter a head again. Circularly we will travel the whole linked list at the last node before just head, because if we move forward then head will again come and then we'll need to travel. So that's the case. We'll travel to the last node until we encounter head, and then what we will do, we need to make the changes on the last node because we are deleting the first node, that is the head. So last dot next should point to head dot next, right? So head dot next is certain second value if we start from head, and the last dot next is pointing to head, so we'll modify it to head dot next, right? And then we free the head, but the pointer needs to be updated. Now head should point to the last dot next, right? So the last dot next contains the new head that we have, right? So the head pointer should point to it, right? So this is a possible case. Now the another case can be while last dot next is not equal to head, right? So we are traversing the list and we are traversing till we do not encounter head again, and the last dot next dot data is not equal to key. So the last dot next data is not equal to key. That means we are getting we are taking the loop until we do not encounter the key. When we encounter the key, we'll get our value in the last, right? So we are making a traversal circularly until we encounter the head, right? And also we do not encounter the key. As and when we encounter the key, we'll stop this and we'll get, okay, at this particular next value we have our key, right? So we'll traverse this last. Now what are the possible cases we have? If last dot next dot data is equal to key, that means the next node data is key, right? So what can be the case? We need to modify it, right? So we'll make a temp which is equal to last dot next. Last dot next we need to delete it, right? Because last dot next data is key. So last dot next we will delete it. We'll take it in a single temp node, as we have taken we have initialized it earlier, right? And then what we will do, will simply modify the pointer, right? So last dot next will be equal to temp dot next, right? So because we need to delete temp, temp dot next is pointing here, last dot next is pointing to temp, so last dot next will be pointing to the temp dot next. That's all, and we will free the temp. This is the possible case, and there can be a case where we have traversed the whole list but we are not able to find the key. In that particular case, we will return no data, right? So we have seen all the possible cases. We have seen all the possible cases. If you are still not clear, then rewind the video and just try to execute this thing on your own. That will make it more clear, right? So this is the possible case. For the traversal, I would request you, it is quite simple. You just try to implement the traversal and please write down the code in the comment section below. Let's see what are the different approaches we have, and if you're still unclear with the traversal, you can mention your points. We can take another video to cover it, right? And if it is clear, then it is perfect. So this is all about the circular linked list. I've tried to touch as much points as I can touch in this particular short duration of video, but the topic is very vast. You can try and explore a lot of things, a lot of questions, and you can paste certain good questions in the comment section below. We welcome all that, right?